Part 3, Geometric Sequences. A geometric sequence is defined like this. The sequence a sub n is called the geometric sequence if a sub n equals r times a sub n minus 1 for some non-zero constant r, and all values n and n minus 1 for which the sequence is defined. So what this means is to go from one term to the next, I'm going to multiply by the same number. So for an arithmetic sequence, we kept adding the same number. For a geometric sequence, we're going to multiply by the same number. And that same number that we're multiplying, we call that the common ratio. So if I want to write the first four terms of this sequence, let's write this out. A sub 1 would be 3 to the first power over 9, or 1/3. A sub 2 would be 3 squared over 9, which is 1. A sub 3 would be 3 to the third power over 9, which is 27 divided by 9, or 3. A sub 4 would be 3 to the fourth power over 9, which is 81 divided by 9, or 9. So our terms are 1/3, 1, 3, 9, etc. So what is our common ratio? 9 divided by 3 is 3. 3 divided by 1 is 3. 1 divided by 1/3 is 3. So when we take one term, divide it by the one before it, that'll tell us what we had to multiply by to go forward. So our common ratio is 3. We start with 1/3. Times 3, we get 1. Times 3, we get 3. Times 3, we get 9. Given the geometric sequence with a first term of -3 and a common ratio of 2, so a sub 1 is -3 and r is 2, let's find the recursive formula. So the recursive formula, remember, says a sub n equals r times a sub n minus 1. And a sub 1, we'll just say equals a sub 1. So in this case, our recursive formula, a sub 1 equals -3. A sub n equals that common ratio 2 times a sub n minus 1, where n is greater than or equal to 2. Let's find the explicit formula. So a sub 1 is -3. A sub 2, we start with -3 and we multiply by 2. For a sub 3, we start with -3 times 2, and then we multiply by another 2. For a sub 4, we start with a sub 3, which is -3 times 2 times 2, and then we multiply by another 2. And we can start to see this pattern. So our explicit formula will be a sub n equals that first term, a sub 3, times that common ratio raised to the power of n minus 1. Notice for a sub 2, we've multiplied by 2 one time. For a sub 3, we've multiplied by 2 two times, etc. So our power on the 2 should be n minus 1. We multiply by 2 one less time than whatever that term number is. So what is the explicit formula for any geometric sequence? Of the first term, a sub 1, common ratio r. So the same thing that we got for part B, we're going to say a sub n equals the first term, whatever it is, times the common ratio to the n minus 1 power. And that gives us the explicit formula for a geometric sequence. So the explicit formula for a geometric sequence is a sub n equals a sub 1 times r to the n minus 1, where n is 1, 2, 3, whatever the term number you're looking for. So let's find the 10th term of this geometric sequence. We need to first find the first term, so a sub 1, which is -1, and then we need the common ratio. So to find the common ratio, 8 divided by -4 is -2. -4 divided by 2 is also -2. That's our common ratio. So one way to find the 10th term would be to keep multiplying by -2 until we get to the 10th term. Another way would be to find the explicit formula and then substitute 10 in for n. And I'm going to find the explicit formula so you can see how to do that. If we were actually trying to find, the 48th term, the explicit formula would definitely be faster. So let's do that. If we have a sub n equals the first term times the common ratio to the n minus 1. The common ratio is -2. So this is what the explicit formula looks like. And now I need to find a sub 10. So I have a sub 10 equals -1 times -2 to the 10 minus 1, or -1 times -2 to the 9th, which is -1 times -2 to the 9th is -512. And negative 1 times negative 512 is 512. So the 10th term is 512. And again, I could have just kept multiplying by negative 2. I have the first 4 terms, so the 5th term would be negative 16. Negative 16 times negative 2 is 32. And I could keep doing that until I get to the 10th term.